Hi all. Yeah, this is Malaypan from Pantech Solutions. I welcome you all to this third day of MATLAB Simulink Masterclass series. And the today topic is motor control using Arduino with the help of MATLAB Simulink. In the motor control, we took today the two motors. One is a DC motor and another one is a servo motor. In the DC motor, the speed control is a main parameter, and in the servo motor the position control is the main parameter. And again, let's check the concept where we are. For example, if you take an application block diagram, so here in the application point of view, there are the four detailed module in that entire target applications. And here the load is the today important topic. So what are the load, how we can choose the load, and how we can control the load with the help of the microcontrollers, main microcontrollers. And here again there are two different concepts. One is how the load can be controlled without any auxiliary circuits by the microcontroller, and the second concept, how the more load is controlled with the help of microcontroller with auxiliary circuits or the auxiliary circuits. So these are all the main two different controlling methods. And in next one, how we can choose the motor load type of motor. There are variety of motors are available in the market. Based on our applications, we can choose the motors. So you just keep engaging with this video. You will get to know about how to choose your motor for your applications. And before the end of the sessions, we will discuss about some project ideas, how we can choose the project, and how we can choose the components to the project, and how we can choose the motors and additional sensors. So those things we will discuss in detail. And the today topic, detailed topic is the motors. In the motors, we took a DC motor and servo motor. In addition to that, some stepper motor also available. So we can see the working principle of the stepper motor. And the second thing, applications where these motors are used in the market, in industry point of view. And similarly, we can do in our research applications also. Right, and the third one, we will discuss how the motors can be controlled with the help of Simulink. That two demo will be provided. And the next topic, that how to choose the motors for our applications. In generally, there are variety of motors are available in the range of motors fractional HP to maximum HP in terms of kilowatt range motors are available. For example, for toys car applications, we need very basic like 1 watt, 3 watt, 6 watt motor is enough. In the case of huge power generation applications, like for example, take a nuclear power plant or in a thermal power plant, so there it will be a megawatt range of motors will be there. So each and every motor, if there is a change in the motor's capacity, then we have to change the controller, like this controller part we have to change, and the power circuit part we have to change, because the current handling will be the major part in the motor control applications. So that we have to choose based on the motor and based on the controlling specifications. So those details we will discuss in detail. First, let us take a DC motor. So here the DC motor is a basic DC motor. I took today's example. So this is today's motor. So this is called a DC motor. It's just a DC motor, right? I mean toy car. This is a toy car motors. It will be in many in the RC controlled toys car, robotic cars or robotic applications. So this will be there. And this motor again, we can use directly to that. High speed with very minimum torque will be there. If you can stop the motor with just your finger itself. So there is no, it's absolutely minimum torque. but we can increase the torque, the same motor we can increase the torque with the help of gearing mechanism. So if you add the gearing mechanism, then you can still you can increase the torque of the machine. So like that we can use in the applications. See, for that, again this motor directly you can connect with the Arduino controller, like in previous block diagram, right? See here, we can control the motor, this motor directly to the Arduino controller. So we can feed the control, the just PWM, if you apply across the variable PWM pulses to the motor, then the motor speed will be controlled. And another, that will not be a perfect method, because already we know that each microcontroller GPIO has some current limitations. So if you assign the GPIO as an output pin, that controller will give you maximum 40 milliampere. In some cases it will be 10 milliampere only. So if you take this package, this same board Arduino Uno with the assembly pack, the current of the GPIO will be the very less. So in that case, definitely we should keep one additional circuit. So the additional circuit, nothing but that is called auxiliary circuit. So this may be this one, that is the power circuit. So from the power circuit we can drive the motor. So again here, there are variety of power circuits are available. If the current is, that is the 0.5 ampere maximum about the load, that is the motor, then default drivers are enough. So the default drivers are nothing but here, there is L293D. So these are some basic drivers available. So this driver will have simultaneously, it will control a single motor and a dual motor, right? If the motor current is more than the 0.5 ampere, then we should keep the solid state switches. So that is the additional circuits called chopper circuit or buck converter circuit or boost converter circuit. So if you keep employing that kind of topology, you can control any range of the ampere in the motor requirements. Okay, so we have to choose the two different auxiliary circuits. If the motor load is less than 0.5 ampere, we can use the basic default driver ICs are available. Still the driver IC will work for 5 voltage or 15 voltage, and different ranges are available that can be verified with the datasheet of the particular driver IC. But this driver L293D will work with the 5 voltage operating. And next one is servo motor. See, the servo motor main construction is similar DC motor, but with additional gearing mechanism. So the same motor, see, actually the servo motor is nothing but a combination of entire things, like the DC motor and gearing set. So for small range of servo motors called small range of servo motors. So this is a small range of servo motors. This motor has only small DC motor, very small DC motor along with gearing mechanism. And some range of servo motors are also available in industry point of view. So they will say they will call all motors will comes under that servo mechanism. So the servo mechanism nothing but there are two kind of servos are available. One is a DC servo and another one is AC servo. For example, 1 kilowatt DC servo in the nothing but 1 kilowatt DC motor will be there, and gearing set will be there, and controlling circuit also will be there. So the controlling circuit nothing but it will be either converter, inbuilt converter with the position sensors. So there will be again the sensors will be there. Again in here there are two types. One is called position controlled servo, and another one is the speed controlled servo. In position controlled servo there are two types. One is entire 360 degree. entire 360 degree, and another one is half of the degree. Yeah, so this is half of the degree, and this is the 360 degree. The range is 0 to 180, and 180, this is 0 to 360 degree. So we can control the position of the motor accurately. Again, for the position control, the people will use a stepper motor and DC motor, but again the position will not be accurate. In the case of servo, it will be, more or less equally it will be accurate. And so today, for today example, we took this type. The position of the servo can be controlled from 0 to 180 degree with a variety of variations. Like we can keep the servo at 10 degree, 20 degree, 30 degree, 40 degree till 180 degree. Again, there will be a lot of considerations are available. So we have to take and we have to discuss in detail that topics. And in the case of AC servo, again there will be one AC motor called any kind of AC motor, say in the induction motor or BLDC motor or PMSM motor or SRM motor. In addition to that, all the mechanisms called the control circuit and position sensors. So there are that kind of motors also people will call in industry, in industrial point of view, AC servo. And so these are all some general applications like robotic applications, conveyor belt applications, camera, autofocus. See, nowadays that the camera is playing a major role in that entire all the type of industries requirements. So again, with the help of a camera autofocus mechanism, we can do some accurate applications and robotic vehicles. Solar tracking systems. Again, here in solar tracking system, again the MPPT method will play a major role. But still, we can change the position of the solar system with the help of this motor mechanism. Still, we can improve the efficiency of the entire solar power systems. So again, that antenna positioning, we can change the antenna without any others help from this remote. It's a remote controlling mechanism itself. And automatic door openers and printing presses, everything. These are all some basic application methods. Let us see one by one. For example, in robotic arm, so take this method. So this application. See here that the position will be from let us take this is the graph. 0th position, and from here to this point. See, let us take this is the 90 degree. For suppose if you keep one servo at here, this will handle this 90 degree without any issues. And if this particular arm will hold the load with a higher torque. So that is the advantages of the servo. Here also we can keep some DC motor, but for low power the torque will be very less in the case of exclusively DC motors. In the case of servo motor, we can increase the torque, that is the load handling capability, by increasing the torque with the help of additional gearing mechanism. So for here we need a 90 degree controlled servo is required. Similarly, if you take this requirement, see here that this elbow mechanism should change its position on very quick manner. In that aspect, we have to keep some DC motor with the minimum gear requirements. So then only that the speed will be huge. And again, that reliability is there, and noise is there. So we have to choose motor accordingly. That the noise should be very, very less. And servo in conveyor belt applications. So again, if you take if you develop some logics, based on the logic, we can remove the colors of the bottle or filled of the bottle and damages. So based on that, we can choose the things. And antenna positioning and camera focusing, auto focusing mechanism. So these are some major thing. Based on this parameter, based on these three parameter, we can choose the motors for our applications. High torque. So here the torque is a combination with the speed. If you need a low speed high torque and high speed high torque and a low speed low torque, so this is a different combination. We have motors can be chosen. And similarly high cost. Some cases we can use the reconditioned motors also. That point we will discuss in detail in that how to choose the motors for our applications. And lifetime of the motors. Some motors will have a number of working hours. For aircraft engines, so the working hours is the major role. They are based on that lifetime of the motor, then people will choose the thing. And in servo motor, in DC motor, there is no any wire connection, so just one is positive and another one is negative. In motor, for toy car applications, if you apply positive to that any terminal, and it will start to rotate in any direction, either clockwise or anti-clockwise. In the case of servo motor, we should keep some points. Like in this, in today's example, we will take this motor. There will be a red, brown, and orange. So based on here motor data, we have to apply the Arduino. We have to configure this Arduino. Then only the motor will work. Otherwise it won't get run. Right. So we will discuss in detail about these things in demonstration. And stepper motor, again there will be a motor mechanism along with some bearings. So this is the cross sectional view of the stepper motor. There will be a depends the applications. We have to choose either a stepper motor or DC motor or servo motor. So here for the micro stepping applications with the high torque, this motor will be perfectly suitable. And again, these are all some applications. Let us check. And today experiment is first we will see that this is a DC motor control application, and we will go for the servo motor applications. Let us go for the MATLAB. Just open the new project, save the project. Before saving the project, you just check work directory is same or not. So for here, just check the work directory. This is the work directory. Here our DC test is our project file. See, the DC test is the project file. In this file we are going to use Arduino PWM. So again, for a DC motor control applications, the PWM is going to control the motor, right? So for that, take a PWM block from the library and also take a constant block, because the PWM block will receive the data, and that is a integer data. So for providing the integer data, take a constant block. That constant block, if you apply 0 to 255, that is the maximum range of duty cycle, right? 0 is the minimum range and 255 is the maximum range. And assign the hardware, go to modeling option, model settings, choose the model setting option. So there will be a hardware implementation option will be there. Choose hardware implementation of your board based on your target board. You can choose. There are variety of boards. I took Arduino Uno. And rest of the things just to keep as it is, whatever it has. And Again, in the solver configuration, there are variety of methods are available. So we will see one by one based on our application. So that just to keep engaging with the entire 30 days class sessions, so you will completely will get to know about it. I will choose this solver application based on our project experiment requirements. Yeah, we assign the hardware and get infinite time. So that's why if you choose that infinite time, we can run the simulation on the entire time. Continuously we can run the simulation. Yeah, that simulation is getting initialized. Once if it is initialized, it will shows you the running option. And now see, actually let us check the hardware. See here, the hardware is Arduino is connected, and I will give you the schematics of this this driver in that LMS portal. You can download this schematics, and already the connection has been established. That DC motor now it's not running because the duty cycle is very less. If you increase the duty cycle, again it will starts to run slowly, right? See here, it starts to run very slowly, and again if you change the duty cycle at so yeah, the speed is very high, right? And again still we can increase up to 255. That is the maximum speed of the DC motor. See how now if you change 100, immediately will the motor speed is getting reduced. But here again, suppose if you reduce it further, the motor will get stopped. Not for 50 data. If you keep increase the 90 data, still the motor is not running. Because that's why I told you, right? We are using this auxiliary circuit, but still we are taking the power from this board itself. For this board, the power is from the computer. Okay, if you assign this board with the additional auxiliary power for this board as well as the driver, instead of Arduino power, if you keep additional power, then still the motor will work. Otherwise, it will get struck. Okay, and again one more important point. For this motor rating is just 5 voltage with a fraction of ampere, like it receives about 0.5 or I mean less than 0.5 ampere only. I'm not sure about that data. The data sheet will be in the data sheet you can get that those details. And the speed about 300 rpm to 500 rpm maximum it will be. If you apply the proper power with the exact current source, then we can increase the speed at rated power. Right? Yeah. And if you take a different motors called some of high power motors are also available. See here, DC motor, some of the DC motors are also available. These quick. See, for example, if you want to control the speed with the maximum, see, these are all some DC servo motors are there. With the help of this DC servo, again here also some gearing mechanism will be there. So for controlling that servo DC motor, you need this kind of facilities you need. So then only we can control the motor with a higher range. See here again 50 voltage with 3 ampere. So if you apply the 3 ampere with 0 to 50 voltage at the armature range, then you will control the motor at a higher range. Accurately you can control the motor. Okay, so in that case you need this kind of additional circuits, not exactly this one. You can put similar kind of mechanisms. Yeah. Yeah, and next one is that servo motor control. For the servo motor control, first we have to change the connections. See, based on this connection we have to connect. So let us go for the connection diagram. I'm going to unplug all the connections. See here, there are the three terminals are there. Ground terminal, brown is a ground. Just to connect to the ground, and power supply, 5 voltage power supply, and data pin. So actually, for in our experiment, I took a 9th pin as the data pin. Yeah, and see here, this position is somehow more accurate than that DC motor control. Okay, so for that we need to add some of additional tool in our MATLAB Simulink method. So for that you just go to add-ons block. So there you will get this block called legacy MATLAB and Simulink support for Arduino control. So this while adding this block into your software, into your MATLAB system, then you can get more facility to control the accurate timing signals, because that servo motor will work up to that 50 Hertz with the range of the duty cycles. See, for example, 0 is the, see, for example, this is the 0 point. If you take this point as a 0 position and this point as a 180 position, so we have to accurately control the position of the motor. So for that purpose, the timing sequence is important. So for that, you just add this block in your package in your system computer, and it will ask you some questions. You just follow, don't omit any steps. Finally, it will get installed. And let's go for the MATLAB Simulink. Close the Simulink. Open Simulink. Take a Arduino block, Arduino servo write. There will be a variety of things. Continuous Arduino standard servo write. Not a there will be two things. One is a standard servo write and continuous servo write. Just to take Arduino standard servo write. Okay, by default, the pin number 9 has assigned. Just to take the default. If you want to change any other PWM, then you can use it. Take a constant block, because here also we have to apply the constant value, because this will receive 180 to 0 to 180. So for the, we have to assign the range only. So save. And open the modeling option, go to model settings, choose the hardware implementation. Here Arduino Uno, choose the Arduino Uno board, and rest of the thing is just to keep. If there is any bug, then it will shows you out where you have to change the block, like that it will get. Just to keep as it is, whatever it has. And see here, in previous examples we have used this function, right? That run and stop function we have used. But for this applications, we have to go to the hardware block, and there are a variety of options are available, and choose monitor and tune, and take this start time as an infinite time, infinite seconds will run, and this is in 2009 MATLAB 19B 2019B. In the case of MATLAB 18 and the previous versions, here the functions will be there called normal, accelerator, rapid, and external mode. So additional thing is external mode will be there. Just to choose that one. So here this is called external mode, right? For in previous version it will be a external mode in this option itself. But in 19B, it's 19B and other versions they have given you option at here. It will get preparing the simulation results. Please wait. I have connected the hardware. By the time you please check. So simulation is running. Actually there are three pins are there. No, I have connected data pin as a so that data pin as a 9th pin, PWM 9th pin, and rest of the things that PWM, not ground pin and 5 voltage pin. Simulation is in background, it is running. Just wait for 2 minutes. It will give you the results. If there is any bug, then we can change in the diagnostic thing. You will get to know about what is the error source. So based on that, we can take a decision. We can there are variety of options are there. See, now that servo motor is turned to nearly to the 0th position. See, about 0, right? I am changing the position, for example 50 degree. Yeah, now that motor has changed to that 50 degree. If you change if you change 150, so the position will be there. And still, see, actually whatever it may be, if you take this as a 0 and this will be the 180 degree, but here due to this motor rating, some cases the motor will have a less reliability. The reliability nothing but it won't give you till exactly the 0 to 180 degree. If I keep 180 degree, then it will gives you the error. So this is called error. If you run this maximum range, the gearing mechanism will get damaged. So this is called reliability of the motor. Okay, so if you, again for the servo motors, in the market, in industry, people have variety of motors are available. So you just choose based on the cost, based on the resolution. So this resolution will also important parameter while choosing the motor. If you go near that range also will give you the problem, like a 170, 78. Let us take 0 to maximum. So from here, if you apply here, 178. Yeah, so this is also a problem. So we cannot run this motor till the maximum end. So this is called resolution. This is called resolution. So by adding all the functions, like whatever we discussed in the previous classes, if GPIO pin 4 is high, then only the motor should run into that exact 120th position, 120th degree. So like that we can add a logic, and then we can develop our applications with this MATLAB Simulink, right? And let us go for the motor selection topic concept. Yeah, see here, let us take DC motor, DC servo motor, and DC stepper motor. Stepper motor choosing. So how we can choose the motors for our application? In case again the DC motor also we can choose in this manner. See here, wherever you need low speed with high torque, comparatively DC motor, stepper motor will have a maximum torque. The torque is nothing but load handling capability. In here, simultaneously, if you need maximum speed with the less torque, the less torque nothing but the torque will be here. So for that application you can choose the DC motor, PMDC or DC motor. So this is for these motors for the tie car applications, wherever you need maximum just the rotation. Then if any loads apply over the shaft, then the motor will get stopped. So for that applications we have to choose the DC motor, but that speed is very less, like 1 RPM, 2 RPM or 3 RPM. Then the high torque should be high, like for example Newton torque nothing but that kilogram, for 1 kg nothing but 9.96 Newton meter. So if you apply that value, then you can get a vice versa. The exact load you will get it, that is the weight load in terms of kilogram. So there you can choose the stepper motor will be the optimum solution. Wherever you need high speed, that is in the range of within this range, you can choose the load. So for example 2000 RPM, but load is about 2 kilo only, 0.2 Newton meter only, then you can choose the stepper motor. In the same condition, 2000 RPM with have to increase the load up to 1 Newton meter, then we have to choose the servo motor. Right? So based on this graph we can choose the motor, and again while choosing the motor, again important topics also there we will discuss in detail. And this is important topics. What is the speed? First factor is the speed range. How to choose the speed? What is your speed, load speed, and how about that value maximum load? Either I mean what the range of the load. If for example, if you take a lift application, there will be a 0% will be there, and the maximum like 8%, 8% or 16% or 50%. So that is the maximum load. So based on that thing, we have to choose it. And the load characteristics. The load characteristics nothing but if there is any absence of human interference, human involvement in that load handling, then it will not be a critical load. If lift is a very critical load, and similarly the medical equipments are the critical loads, and wherever that human involves, by applying that load for that load will handle that human facility, then that entire load comes under that critical load things. Then remaining thing not critical load. So for that we can use some resolution based factors. And available power supply. Next parameter is that available power supply. For example, if you are applying, if you are running the, if you are developing one robotic applications based on that domestic or industrial requirement. If you take a domestic applications, in the domestic applications like vacuum cleaner is a one small kind of robot. I mean the vacuum cleaner is the small kind of robots. So there you have to choose the available power supply. So vacuum that the entire load will have a motor load and battery load and additional circuits. These are all the entire load value, that is a torque value. And second thing, available power supply. If you keep increasing the number of voltages, like instead of 6 voltage, if you keep 72 or 48 voltage, the battery size will be huge. So in that case, we have to go for the higher range of motor, right? And otherwise, if you choose the 6 voltage battery with the ampere rating is a little bit high, or again there are battery in the battery bank, variety of batteries are available. So based on that weight, based on ampere rating and weight and voltage, we can choose the battery, right? And the next parameter is that resolution parameter. The resolution or efficiency. If instead of the rated power, rated load and rated speed, if you accept the range, like so for example, if you take a 2 kilo Newton meter load and 1500 is the RPM, instead of that, if you apply 10%, instead of 1500 RPM, the load will work, the motor will work up to 1300 RPM, and the load can be handled up to 1.5 kilonewton meter. If you accept, then you can go for the range. Otherwise, we have to check the motor behaviors. That data can be available from the manufacturer. So we can check the, well, again there will be a load, output, performance curve, and load curve will be there. So based on that you can choose it. And similarly that cost, either for academic purpose, for academic prototyping purpose, no need to go for any new motors. So just to go, you can go for reconditioning motors also. In reconditioning motor in your nearby your local rewinding shop, so there you can get a reconditioning motor. For require, I mean if you need, then you have to choose. Otherwise, for robotic applications, then that is low cost, low sizing motors, no need to go for that reconditioning motor, just to go for the fresh motors. In the case of 1 HP or 0.5 HP motor or 2 HP motor, if you need, you can directly go for the reconditioning motors. There you can get almost 10% of the original motor cost. So these 6 are the important factors for choosing your motor applications. And some project thing what we have chosen the motors. Let us take this project. So this is a small DC small speed control of DC motor using single phase full converter. See here, we took actually the concept is DC motor control, right? So the DC motor control is equivalent. This is a universal motor. This motor will work under AC as well as DC based on that additional mechanism is there. So we took this motor as a DC motor. Okay. Again, this is a project prototyping. So we took this is a 100 voltage motor. For 100 voltage motor, that the power supply is about 24 voltage will be the maximum power supply. The 24 volt are for this project we took a 24 voltage with the 2 ampere power supply. But in the case of your thing, again this motor will work up to 230 voltage motor also. For proving our concept, like our algorithm works very fine. This algorithm will work for any range of this motor, like 24 voltage or 100 voltage or 220 voltage. That is the main objective of this project, right? So that's why we choose this motor for our applications. Otherwise, so I have to verify 1 kilowatt DC motor with this same thing. In that conditions, we will choose definitely the like a Kirloskar or variety of the things are there. Kirloskar and ABB motors are there. From that manufacturer, we will took a motor. So that kind of motors also we have. If you go to that product power electronics and divisions, there you can get this is induction machine. So this is a Kirloskar make motors. So we will use this kind of motors. So this will be highly ranked. If you buy this motor from the direct manufacturer, they will give you the exact data sheets. So this motor maximum capacity and what is the minimum capacity, those things we will people will give you. Like that we can choose the motor. And another one, if you take this example, see here. So this is a small automatic parking systems. So here we took a DC motor with additional gearing. So the gearing nothing but wherever if you increase the spindle of this mechanism on this motor shaft, it needs a quick response as well as that load handling is required. So here the motor will work for 10 RPM with the maximum range of like this weight about will be about 100 gram, 100 to 150 grams will be there. That yellow color strip, right? So this strip will have about 150 grams. So to handle this requirement, we choose this motor. If again we can keep servo, basic servo also we can keep here, but by changing that exact here I no need for exact position. If I want to just close the gate, so for that only I choose this DC motor, because DC motor cost is comparatively low than the servo motor. Right, so here again the cost also will plays a major role, right? So based on these factors, you have to choose the motor, right? And so like this you can choose and you can start your research applications. And again, yesterday we shared some secrets to increase your learning habit. So in that yesterday mail, we have given you some videos. That video has created millions of achievers in the worldwide. So just to follow the video, whatever it speaks, and definitely will help you, and it will impact. It creates a lot of impact in your career. Because I am following that same video, whatever I listen that video daily on daily basis. But whenever I wake up, my first job is that we have to listen. I have to listen the video. So I from inside on me, it creates a lot of changes for past 3 months. So I advise you to listen the video. Again, the technical skill set is second thing only. But the first thing is the mindset. First we have to set the mind whether we have to listen this 30 days class or not. So just we are attending and then leaving is not, it won't gives you any change in your research or in your life. So I hope today's session has been useful to you, and if you have any queries, you please comment it. I will try to add in this next classes sessions. Thank you very much.